finally we're done with all the data preparation, might be what you're thinking now. And of course, we're gonna go to the really, really sexy part while we're all here, the real blockbuster, building your first AI, right? Our little yellow robot here also, he looks very excited. Yay, give me the first AI already. So let's dive right into it. What we're gonna look at is a random forest model. And to understand the full forest, we'll first look at single trees inside the forest. So that might be what your tree look like. This is a decision tree. We made it look a bit fancy so it actually looks like a proper tree. But what it really does is you start here and the question is, did the passengers arrive? And then you say, okay, first thing I'm going to look at, let's say maybe age. Why did I pick age? Well, no one knows. We'll talk about that later. If the age was below 25, well, I know that we saw in the data, children and ladies first seem to be a bit of the theme there. So if the age is below 25, I'm saying that might be considered to be slipping into the child bracket if he or she is lucky. So goes in here. If not, that's a bit more critical. Well, another thing we saw on the data was if you pay a lot for your room, you also seem to have a higher probability of surviving the incident. Let's say, okay, you might not be considered as a child, but if your fare is really high, I'm still gonna say, okay, you're gonna be alive. If both of these things are not true, I'm gonna say you're dead. This is how we do rules by hand, and honestly, that's also how the machine does it ultimately. The only difference is there's a lot less guesswork, and we're going to do a lot of optimizations on here. Next thing, we'll see why that is, because you remember we were saying, why should I use the age first? Why don't I start with the fare actually? And the other thing is, why do I use 25 to cut off for the age? Maybe I'm saying, maybe if someone is below 18, it tells me much more about that person. Or maybe I want to say, I have here one decision that says age below 25, and then afterwards I have another one that says age below 18. So I have both values even inside. So there's a lot of decisions just on one single thing here on that tree. And ultimately we want to stack them all together here to have the full tree. So even on these two simple decisions here, I can switch the values and I can switch the position or completely switch it. I can even have more trees here, more branches. So there's a lot of decisions I have to make just for seemingly simple stuff. And if I want to do that by hand, what typically happens is we start out understanding what happens, but as the rules interplay together, it really becomes a giant furball and no one knows what's going on inside for real. Just the example we saw right now, we have 14 different variables that we could pick for that first stem here. And for these 14 different variables, there are 283 unique values. So in your whole X matrix that we created very painfully in the data section, you have 283 unique things inside. So ultimately, if I wanted to build a decision tree that just has 4 of these nodes here, so a node is one of these brown boxes, each one is a node. If I wanted to build a tree that has 4 of these nodes, I first have to pick essentially down to one value that is 283 times 282, etc. So I've got 6.3 billion different options. While yes, there are some of these options that you can rule out, I'm pretty sure that in the end there will be a few thousand left that look really, really enticing. Right? I would have real challenges deciding between these few thousand, and I would be left with a lot of uncertainty. Well, now the great news is we have models that can actually find the optimal way of building this. Let's go for a real life example. It's gonna tell you very tangibly why building that by hand? What is the real life impact on people's life of doing something like that? Initially, it sounds like a shortcut because maybe the regulator loves it. If we build the rules by hand, it's from humans. We must understand it, therefore, so the regulator is going to fly easy. And by the way, we can do something very similar with the computer built models by saying, okay, I'm just putting something like a Shapley value on top of my model, and then I know for every single decision why that was taken by the model. But that being aside, there are real use cases. Let's just take Live Asia. That's a real business trip I myself was taking one time. I came into a business unit, and the business unit, they had already been working quite a lot on building rules. They had a few thousand rules by the time I arrived. It was 13,000 rules just to take every single decision. And mind you, every single rule was written by hand. So what it really meant is a lot of the people on the ground in this business unit did not have public holidays, did not have weekends completely off for quite some time because they've been so busy crafting the rules. And this is for real, we're not making this up, right? I actually talked to the colleagues, to some of them, and it was quite heartbreaking. Now, the great news is we sent in one of our phenomenal data scientists, and that person did very similar stuff to what you're going to be able to do at the end of this course, and within 10 days, we had an optimal version of all the rules playing together, and the accuracy was much, much, much higher than it was before, and everything to be updated to new information. Maybe the customer's mindset's changed, maybe the market has changed. So taking these updates into account, the whole cycle took 20 seconds and not several weeks anymore.